Hello everyone, my name is Daphne Miedema and today I'll present the paper So Many Brackets, an analysis of how SQL learners mismanaged complexity during query formulation. This is joint work with George Fletcher and Eftimia Ayvaloglu. In this paper we discuss SQL, or SQL, which stands for Structured Query Language, and it's the original method of interacting with relational data. It's widely used in business and also a core part of database education. Research on difficulties of learning SQL started almost immediately after its introduction as a query language. Already in 1983, William Ogden and Susan Brooks discussed the issues with querying for non-professionals. One of these issues is the high cognitive load that comes with remembering the database schema, its attributes and relations. Another aspect for high cognitive load for SQL is the query formulation process itself. In translation from natural language to SQL, you need to keep in memory what has and what has not been translated. This is especially tricky for where clauses, which you can't translate literally, but have to infer from the natural language. Another early critique on SQL is its strict syntax. According to Ogden and Brooks, these can lead to spelling errors, synonym errors, syntax errors, punctuation errors, and language errors. A long list. Another large issue for novices with SQL is that the Database Management System, or DBMS, only provides feedback on syntax errors. Other error types, such as semantic errors, logical errors, and complications, are not caught. This makes it more difficult for novices to find and repair such errors. The final factor I want to introduce is that of prior knowledge. The first element of prior knowledge is that of problem-solving approaches. Database courses are typically not the first courses that computer science students take. They have typically learned about one or more imperative programming languages beforehand. Then, learning to use SQL requires a very different method of problem solving, as SQL is a declarative language. This can lead to many errors in query formulation. And furthermore, other course material may influence the query formulation too by creating misconceptions for SQL, as we describe in our ICER paper from last year. In this presentation, we introduce a newly uncovered factor, which is self-inflicted complexity. So, what is self-inflicted complexity? Let me explain this by means of an example. In our study, we analyzed the log files of student homeworks for a database course, and one of the questions to be answered was find the name of the product that is sold for the highest price and the name of the store that sold that item for that price. Now, this is an attempt by participant 99 and can also be found in our paper. The query attempt is incorrect for a couple of reasons. One issue is that it compares pname to PID, which are two different attributes of different types. The second issue, which you can deduce from the database schema, which is presented next to it, is that pname is not part of the purchase table. Instead, it needs to be gathered from the product table and connected by means of the foreign key PID. Most likely, the participant upon execution of this query received the error message that the column pname does not exist. An experienced programmer, in case of such an error, would likely grab the database schema and examine where they went wrong. But that is not what this participant decided to do. Although we do see some evidence that the student tried to solve both issues, pname is now linked with pname, PID is linked with PID, and the participant introduces the product table. However, at the top they still have a pname, which cannot be gathered from the purchase table. What we can see from the differences between the queries is that the participant has made many changes, including some that significantly increase the size and complexity of the query, such as the addition of deeper nesting and the comparison of the S name. Regardless of these changes, neither of the queries are correct, and they both lead to the same error message. Although the student wrote a longer query, they did not progress as they have not addressed the error message. This behavior of increasing the complexity of the query without addressing the issues of the query is what we call self-inflicted complexity. To quantify this further, suppose a participant wrote a query with a syntax error. Then in 36.8% of subsequent attempts, the query size increased. For brackets, an important domain-specific complexity metric for SQL, the number increased in 8.6% of attempts after an error. In general, in our study, we find that participants write overly elaborate queries containing unnecessary elements, overusing brackets and nesting, and incrementally building queries with persistent errors. If you want to know more about our other results or on managing complexity and our methods, please feel free to reach out to us on the conference platform or on Twitter. Thank you for watching.